Imagine, if you will, the mobile home of tomorrow. Connected to outer space, it controls the lights, the locks, the water. It knows when you've come home, and it knows what to do. A home that thinks for itself. They call it Smarty Van. All of it in a box no larger than the family radio set. Tonight, we dissect each component.
I'm going to walk you through every component in the box, and more importantly, why we chose it, including why we disabled Wi-Fi on the main controller, plus how we remotely control drawer locks. All right, let's get into it. This is the Smarty Van box. Everything that controls or connects Smarty Van 2.0 lives in here. There's a router, a PoE switch, a compute core, and a bunch of relay modules. 6 runs of Cat6 going in and out of this box, and none of them carrying Ethernet. A clever trickle charge circuit for the AGM starter battery, and somewhere in there, something that controls the drawers. And we'll get to all of it. But none of this was an accident. Every component you see in here was modeled in CAD before a single screw went in. I made an entire video about using augmented reality to plan this build, and I'll link to that below. We'll pick it apart system by system, starting with the brain. Now, Home Assistant actually runs on the compute core, and I made a whole video about choosing a Home Assistant server that I'll link below. But the compute core can't flip a relay or read a switch on its own. It needs something that can reach into the physical world, and that's this. I call it the brain, but it's a Waveshare ESP32 module with PoE Ethernet 8 digital inputs and 8 digital outputs built right in. It runs ESPHome and it talks to Home Assistant over Ethernet. Wired, not Wi-Fi. Here's the thing. Every ESP32 has one radio, and a radio can do only one job at a time. Wired up with Ethernet instead, and the radio is completely free. And what do we do with a free radio? Bluetooth. Sometimes hardwired isn't realistic. Fridge temp sensors, presence detection beacons, those are Bluetooth, and that's exactly what the radio handles. We even made a tracker for pets. There are also digital inputs for switches, leak sensors, and door sensors. Physical signals coming in over Cat6, including one-wire temp sensors, connect directly to the brain via an available GPIO. Everything the van can sense and everything it can trigger flows through here first. In Home Assistant, there's one status entity. Everything's healthy, or exactly which module isn't responding. The onboard LED changes color to match, so you don't even need to open Home Assistant to know something's wrong. The brain knows what's happening, but how does it reach everything else in the box? That's the nervous system. The goal from the start was to have one ESP32 handle as much as possible. Bluetooth, digital I/O, presence detection, and relay control. One device, one config. But we needed a lot of relays, more than one board can handle on its own. So instead of adding a second or third ESP32 to the network, each with its own config, its own Wi-Fi connection, its own failure points, we went a different direction. MODBUS. Using MODBUS, the brain sends a command, a device responds. Think of it like a network, but for industrial control hardware. Simple, reliable, and ESPHome speaks it natively. Standard MODBUS wiring is serial. You daisy chain from device to device, which means one bad connection and everything downstream goes dark. It's also inconvenient wiring in a van, just not ideal. So instead, we're using a star topology. This is the Waveshare RS485-HUB. The brain connects to it, and each device gets its own dedicated RS485 home run back to the hub. Clean, serviceable, easy to wire, and no single point of failure. Now, what is it actually controlling? The muscles. The brain thinks, the relays act. We're running 3 relay modules on MODBUS, each one switching loads the brain can't handle directly. Trail lights, water valves, the pump, Starlink, basically anything in the van that needs to be switched on or off. Here's what I love about this. These relay modules are dumb hardware. No Wi-Fi, no ESPHome config, no firmware to manage. All the intelligence lives in the brain. If a module goes bad, you swap it out, set the MODBUS address on the new one, and you're back. No reconfiguring what it controls, no reflashing ESPHome in the field. Now, one of these relays is doing something a little unusual. It's switching a 13.8 volt 8 amp constant current DC regulator, which trickle charges the AGM starter battery. A smart shunt monitors the starter voltage through the Victron Servo GX and into Home Assistant. And when the house batteries have power to spare and the starter needs a top-up, it happens automatically. This one was a Discord idea. Jeff, if you're watching, thanks for the simple solution. That's the kind of thing that comes out of the Discord server. If you're not in there, the link's below. It's free, and as Jeff just proved, there are a lot of good ideas to be found. And while we're at it, a very special thank you to all Smarty Van members, especially our top-tier Rhodes Scholars. Your support keeps this channel going, and we can't thank you enough.
These are the Rhodes Scholars, the ones who keep us moving forward.
All right, not everything lives in the box. This is a Waveshare MODBUS RTU I/O module, remotely mounted running back to the RS485-HUB over a Cat6 pair. It drives the mag locks in the galley drawers. Only 0.2 amps each, the I/O channels handle that no problem. And it means we're not running wire back to the box for every single mag lock. The drawers lock and unlock on command from Home Assistant all through the brain. So brain, nervous system, muscles are covered. Now for everything that keeps them running, the support system. We are using a Peplink router and a Starlink Power over Ethernet mod, plus a LinaVision PoE switch, the backbone of all network connectivity in the van. I made an entire video about this setup, and I'll link to that below. Then there's the 5-volt rail. It powers the low voltage sensors and microcontrollers, DS18B20 temperature sensors, M5 stack micros like the indoor air quality sensor, and Tilty for leveling the van. And don't forget about the capacitive touch switches. There's a video on how I created those as well. Then there's the DC distribution. I'm using the clever Wago lever nut blocks from Pekaway. Clean, serviceable, and no ring terminals required. These have already saved me hours on installation. Huge thanks to Pekaway for sending these along for this build. Our lighting will be controlled by a 15-channel high-frequency PWM dimmer. That one will get its own video, so stay tuned. And here's where those Cat6 Ethernet runs land. 8-position DIN rail terminal blocks breaking out every cable coming back from around the van. Every switch, every sensor, and MODBUS lands here first. Last one, the compute core. Home Assistant, AI acceleration, GPS radio, all running right here. I made a video on choosing your Home Assistant server, and you can find that below. That's the full Autopsy: brain, nervous system, muscles, and support. The systems that make up Smarty Van 2.0. If you're having a nice time, how about another one?
Imagine once again a home that follows you, not fixed to a foundation, but built on 4 wheels and a dream.